Dear students, today we're going to focus on graphs of straight lines. This lesson will be divided into two parts. The first part, we're going to do the theory part. What is the equation of a straight line? What do letters stand for? And so on and so forth. And the second part on plotting straight line graphs. Okay, so let's start from the theory part. So every straight line has an equation. The equation of a straight line is y equals mx plus c. That's the format. Normally we're going to see it with numbers. For example, let me write down a couple of examples. For example, y equals 2x plus 3. Okay? For example, y equals minus 3x plus 4. For example, y equals half x minus 7. Alright, so those are different equations of straight lines. As you can notice here, there is a number instead of m and a number instead of c. Okay, this is m, this is c. M, c. M can be a positive number, negative number, a whole, a fraction, and even the value of c. So, what do those letters stand for? First of all, x and y stand for coordinates. C is the y-intercept. Let me explain. The y-intercept is the point on the graph where the line meets the y-axis. Okay, so it is where the line meets the y-axis. So if we had to see a sketch of a graph, we'll see something like this. Okay, so I have my x and y axis. Okay, these are the x and y axis. We're going to have a line. For example, this is the line. The point where the line meets the y axis, okay, this point here is the y-intercept. So, then we have m. M is the gradient of the line. Gradient, slope, how steep is the line? How steep is the line? So different lines will have different gradients. If we go back to these three examples here, this has a steepness of 2, this of negative 3, this is 1/2. As we can see, a steepness of 2 is much more than 1/2. So even if we had to draw that line, we'll notice which is the steeper one, and that will have the gradient of 2. Now we have, I'm going to continue talking a little bit about gradient. We have 4 types of gradients. We have 4 types of gradients, which are the following. We have what we call a positive gradient, a line going upwards. We have a negative gradient. Then there is the zero gradient, the horizontal line, and then there is the vertical line, which we say has an infinite gradient. Okay, an infinite gradient. So lines of this form will have a positive gradient, for example 2. Okay, lines of this form, like this one which I have drawn here, will have a negative gradient, for example -3. A line which is horizontal will have a 0 gradient, so it would be, for example, y equals 4, because the number multiplying x is 0, and an infinite gradient will be a line of the form x equals something. Let me write down just one example beneath each. For example, positive y equals 2x plus 5. Negative y equals minus 3x plus 1. 0 gradient y equals 5, for example. Infinite gradient x equals 2, for example. Okay, so those are the 4 different types of gradients which we are going to meet. Now, we need to know how to find the gradient. So, finding the gradient, By definition, gradient is defined as difference in y divided by difference in x. In short, delta y on delta x, or y2 minus y1 on x2 minus x1. I will be using this, okay? I will be using this. Y2 minus y1 on x2 minus x1. Now, to find the gradient, we would need a pair of coordinates. So, for example, I'm going to write an example. A line passes through the points A 4,2 and B 6,8. What is its gradient? Now, as we can see, we have two coordinates, A 4,2 and B 6,8. We are going to decide which one of them is number 1, which one of them is number 2. It will not matter. This is x, this is y. This is x, this is y. Those are coordinates. I'm going to say A is number 1, so I've written down 1, and B is number 2. So the gradient is y2 minus y1. Remember, m is the symbol for gradient on x2 minus x1. Now substituting values, y2 is 8, y1 is 2, x2 is 6, x1 is 4. So I have 6 divided by 2, that's a gradient of 3. It is a positive gradient. Okay, let me work out another example. Okay, find the gradient of the line passing through A minus 3,5 and B 2, minus 6. Okay, I'm going to do the same thing that I've done in the other example. So I'm going to say this is x, this is y, this is x, this is y, this is 1, this is 2. It will not matter. Okay, it doesn't matter in which way you write them down. So the gradient is y2 minus y1 on x2 minus x1. So y2 is minus 6, y1 is 5. So that's minus 6 minus 5 over x2, which is 2, minus x1, which was minus 3. So I have minus 11 on minus minus is plus. So 2 plus 3 is 5. So that's minus 2.2 or minus 2 and 1/5. Okay, in this case, this time it is a negative gradient. Okay, now, knowing this, knowing how to find the gradient, we can find also the equation of a line. Now, there are 3 ways how to find the equation of a line. I'm going to describe them one after the other. So, the first type, in the first type, we are given both gradient and y-intercept, and we just need to write down the equation. Normally, this is a problem which comes out during your mental exam. So, finding the equation of a line. Finding the equation of a line. Number 1, you are given both gradient and y-intercept. So basically you don't need to find anything. Let's work out an example. Write the equation of a line having a gradient of 2 and y-intercept of 6. So if we look at our equation, y equals mx plus c, the gradient is 2, the gradient is m, so we know that m is 2. The y-intercept is 6, so we know that c is 6. So substituting, we get y equals 2x plus 6. Very straightforward, a very straightforward problem and a very straightforward answer. Sometimes you are given the gradient and y-intercept, but a little bit hidden. For example, a line is parallel to the line y equals 2x plus 4. If this line has a y-intercept of 7, what is this equation? So, here we have something which is very important, the word parallel. What do we need to know? Parallel lines imply have same gradient. Parallel lines have same gradient. So from this equation, we get that the gradient is 2. We're told that the y-intercept is 7, so y-intercept of 7. So the answer, when we compare that to y equals mx plus c, the answer is going to be 2x plus 7. So y equals 2x plus 7. Okay, so there we have another example where we were given the gradient hidden in the problem. Okay, it was not so straightforward as the other one. So that's the first one. We were given everything and we needed to find the equation. The second is when you are given two coordinates and gradient, and y-intercept to find the line. For example, the line y equals mx plus c passes through the points 0,3 and 4,7. Find the equation of the line. So, when we analyze these two coordinates, one of those two coordinates is a very important coordinate, and that is the coordinate 0,3. Why is that so important? This coordinate means that that point lies exactly on the y-axis because it has an x value of 0 and the y-axis of 3. So that tells me that the y-intercept is 3. So we are given the y-intercept, somewhat hidden, but we are given the y-intercept. Now we have those two coordinates, 0,3 and the coordinate 4,7. The equation is y equals mx plus c. We already know that the y-intercept is 3. We need to find the gradient. So I'm going to do as we did in the other examples. X, y. This is 1. This is 2. So gradient is y2 minus y1 on x2 minus x1. y2 is 7, y1 is 3. 4 minus 0, that's 4 on 4, that's 1. So now we can write down the answer. Y equals 1x plus 3. Y equals 1x plus 3. Okay, so there we have the equation of this line. Okay, the third example is when you're given just two coordinates and you're let to find the equation. So the third one, okay, if you're given just two coordinates to find the equation of the line. Mela, let's start with an example. Find the equation of the line passing through A 4, minus 1, B 6, minus 5. So I have those two coordinates and I need to find the equation. Remember, our equation will be correct when we find both the gradient and the y-intercept. So from those two equations, I can start by finding the gradient. So I have x and y, x1, y1, x2, y2. Finding the gradient, m equals y2 minus y1 on x2 minus x1. That's minus 5 minus 1 on 6 minus 4. There we have minus 4 on 2, which is minus 2. And we have found the gradient. So the equation y equals mx plus c is partially worked out. Y equals minus 2x plus c. Now we need to find c. To find c, we need a value for x and a value for y. But we already do have two of those, because if we choose one of the two equations, for example, I'm going to choose a, coordinate a, 4, minus 1, tells me that x is 4 and y is minus 1. Having that information, I can substitute this into the equation which I have just written. So y equals minus 2x plus c. Putting y is minus 1 and x is 4, I get minus 1 is minus 2x plus c. Note that here c is the only unknown, so we can work it out. So minus 1 is minus 8 plus c, so c is minus 1 plus 8, and that is 7. Okay, c is 7. So we can write down the answer now. Y equals minus 2x plus 7. Okay, and we have found out what is the equation of the line passing through those 2 points. These are the 3 different ways how to find the equation of a line. Right? Now, the next part of the lesson will focus on sketching and using the sketch of a line. So now you'll be given the equation. We need to sketch the line and use that information. So let's see. Sketching a line. So let's see. Sketch the line y equals minus 2x plus 8. So suppose we need to sketch that line. First of all, that line gives me 2 very important pieces of information. By now you are accustomed to them. These are the value, this value, and this value. Okay? We know that minus 2 is the gradient, and we know that 8 is the y-intercept. Note that this is going to be just a sketch, not a plot, so there is no need to worry about scales, etc. Now, we have that the gradient is minus 2, the y-intercept is 8. It means that the gradient is a negative gradient. Negative meaning the line will be something similar to that. And we know that the y-intercept is 8. So 8 is the place where the line meets the y-axis. So if I need to sketch this line, it will look something similar to this. I have a set of x's, x and y, and the line is going to pass through 8 on the positive y-axis, going down. I know that this is 8. I know that this is the line y equals minus 2x plus 8. There's only one thing which I need to find. The point where the line meets the x-axis. I need that coordinate. That's important. So you need to find where the line meets the x-axis. Now, to do this, you need to take out the equation and substitute y is equal to 0. So the equation was y equals minus 2x plus 8. I am going to substitute y equals 0. And I'm going to solve this equation. So I get to x is equal to 8. So x is equal to 4. So now I have found out that this value here is 4. And that is a complete sketch. So to have a complete sketch, you should have a correct gradient, you should have the value of the y-intercept and the value of the x-intercept. Those are two very important points. Okay? Now, after doing a sketch, you may be asked many questions. Because, as you can see, for example, here we have formed a triangle, so I can ask you something about the triangle and other things. I'm going to show you an example, okay? So we're going to see an example after this. So example, sketch, the line y equals 2x plus 12 meets the x-axis at A and the y-axis at B. Sketch the line, hence find 1. The coordinates of A and B. 2. The length of AB. And 3. The area formed by triangle AOB, where O is the origin, the coordinate 0, 0. Okay? So we're going to start from the line, knowing what is the line. So we have y equals 2x plus 12. What do we know? We know that the gradient is 2, so it's positive. The line goes up. We know that the y-intercept is 12. So let's start from the sketch. So we have something like this. We have the y-axis, we have the x-axis, and the line goes up, passes from 12. So the line goes up, passes from 12. We know that this is 12, okay? We know that this is 12. This is the origin. We need to find this value, and we said to find that value, we place y is equal to 0 into that equation. So 0 equals 2x plus 12. So minus 2x equals 12. So x is 12 divided by minus 2, which is minus 6. So that's a value of minus 6. Now I am told that it meets the x-axis at A, so this is A, and the y-axis at B, so this is B. So, number 1. What are the coordinates of A and B? So A is the coordinate minus 6, 0, and B is the coordinate 0, 12. That's number 1. Number 2, I need to find the length of AB. As you can see, AOB is a right angle triangle. So, taking that right angle triangle, AOB, I know that this is 6, and I know that this is 12, because those are lengths, we don't take negative, okay? So, AB squared, I'm going to use Pythagoras theorem, is 6 squared plus 12 squared. So, AB squared is 36 plus 144. So AB is the square root of 180. And you use your calculator to find the square root. This gives a value of 13.4 units. Remember, these are not centimeters or meters or millimeters, they are just units. Okay? Number 3, I need to find the area formed by triangle AOB. So I need to find the area in this triangle. Remember, area of triangle is base times height on 2. The base is 6, the height is 12. So 6 times 12 divided by 2, which gives 36. Again, they are units, okay? So they are 36 square units. Okay, so this is how to find a sketch and how to use the sketch of a line. Now we're going to see how to plot this timeline. So this time we need graph paper, and we're going to plot. We're going to be very accurate. Okay, so plotting a line. If you have your calculator in hand, you can use it. Okay, so you can pause the video, get your calculator, and we're gonna use it. So plotting a line. Now to plot a line, we need a set of coordinates. The set of coordinates might be given to us, or else we need to find the coordinates and then plot the line. So I'm going to start by writing down an example. For example, plot the line y equals half x plus 3 for values of x between minus 6 and 2. So suppose we have that problem, okay? We're just given the equation of the line, and we need to plot that line. Now, we can go to our scientific calculator, okay? You can find your scientific calculator. Choose your mode, and mode choose table. Okay, your display will show fx equals. Now once your display shows fx equals, you can start writing down your equation. So now we're going to type the equation. So you're going to type half, you can use your fraction button, x is done by pressing alpha button. It is on the top part of the calculator, and then close brackets. Okay, so it's alpha and close brackets, half x plus 3. Type equals. After typing equals, you will see a start, an end, and a step. In your start, you're going to type minus 6. So start type minus 6. In your end, you're going to type 2. Step, we normally type 1. It depends. When you press the last equals, you're going to see something as follows: x and fx, and you're going to see a table. Underneath x, you're going to see minus 6, minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, and 2. And fx, you're going to see 0, 0.5, 1, 1.5, 2, 2.5, 3, 3.5, and 4. Now, once you have formed your table, that's our table, this is x, okay, and this is our y, because your calculator denotes y by fx. So now we can plot the graph. I'm going to show you on this same page. Now, when drawing a graph, you have to be very careful to have a correct scale. That's very important. You need a correct scale, and you need also to fill the page as much as possible. Now, I'm going to use a scale which is not exactly your scale because I don't have your graph paper, but so x is from -6 to 2, and let me take in this a little bit, and y, as we can see, is from 0 to 4. So in this case, we don't need values of y which are negative. So this is 2, this is 1, minus 1, minus 2, minus 3, minus 4, minus 5, and minus 6. On y, I need up to 4, so this is 1, this is 2, this is 3, this is 4. As you can see, I have used different scales on the two axes. This is acceptable, you can do this. Another thing which you could also do, and which even I could have done in this case, I could have left 1 out, minus 1 out, minus 3 out, because it's usually normal to only write down values which are on the bold lines of your graph paper. So then I'm going to plot. So I have -6, 0. So this is -6, 0. I have -5.5. I have -4, 1. I have -3 and 1.5, -2 and 2, -1 and 2.5, 0, 3, 1, 3.5, and 2, 4. Now I've got enough coordinates, even 2 and 3 that would have been enough, but now I have enough coordinates to plot the line. And there you have it. Okay, so now this time I have plotted a straight line. It's normal also to write down the equation y equals half x plus 3. Okay, so we have plotted our straight line. Sometimes we need to plot more than one line on one graph, but it doesn't matter how many lines you plot on your graph, as long as you have a correct scale. Okay, so that is all about straight line graphs. This same method which we use to form the table, we're going to use it in our next lesson when we need to plot graphs of curves. Okay, so that's all for today. Thank you for your attention.